Hi everyone, I'm Ankit. I'm a software engineer at Uber in the real-time analytics team here. And today I'll be talking about the time series query engine support that we recently contributed to Apache Pinot. And before I dive into the time series query engine and time series and observability, let's do a quick primer on Pinot. So Pinot is a OLAP database which is capable of ingesting data from a bunch of different sources, real-time sources, batch sources, and so on and so forth. And it is very fast, like it gives like milliseconds of latencies in queries, and you can run them at thousands of QPS. And it's used for powering end user facing analytics, but it's also used for like a lot more things. But that's a general use case spectrum that Pinot is most famous for. And so the real-time data ingestion part is one of the most popular features of Pinot, and that is what like made Pinot really famous in all of the big companies. So the idea there is that you have a message stream, let's say a Kafka stream. You'll be able to ingest it into Pinot, and Pinot pulls data natively from Kafka or the message stream that you have, and your events get converted to rows in a table, and you have columns as you would in a regular relational model. Think of like MySQL databases, Postgres databases, and so on and so forth. And you can then just like immediately query it with SQL. And aggregations are again like the most common use case of Pinot, but you can also like do select only queries, and those will also work well and they scale well. But aggregations is one of the most important features that Pinot provides, given it's an OLAP database. So that's how usually the flow is. But when we in this particular presentation, we'll talk specifically about observability. And to talk about like Pinot for observability, I'll start by talking about generally speaking like SQL for observability, just so we can understand like why would you want to build a time series query engine in a database which already has a ton of feature and it's already quite successful. So whenever you start with observability, you usually start by graphing things in a UI. And you ideally are looking for lines on a graph. And the first notion that you deal with there is that you have a notion of time range, a given time range that is specified in the UI. In this case, like I've taken screenshots from Grafana. So usually your dashboard will be looking at last 3 hours of data or a specific time range of data. And the first challenge that comes with using SQL for observability is that you have to find a way to put this time information, the time filter, into your Pinot table. And that is the first challenge that comes in, because usually in most of your Grafana, let's say you build a Grafana connector on your own, and that actually brings me back to the fact that we don't have a general open source Grafana connector for Pinot yet. Like most companies have built their own versions. But anyways, I digress. So usually, if you have a Grafana character, then you would be writing SQL queries, and you would be expecting users to write SQL queries there, because users want like flexibility in like how they want to run the queries. You can obviously like build abstractions on top of it where they don't have to write the queries, and they just only have to deal with certain expressions, or you automate as much as possible. But SQL still remains like at least at Uber, it remains one of the most popular ways to query your data, and that is where people want access to SQL and they want to edit SQL in their Grafana dashboards. So the first challenge here is that how do you do time filters with SQL in the play? So one of the usual strategies to work around this is that you add some sort of macros in your connector. In like again, I'll talk about Grafana, but like you usually have a concept of macros in the visualization platform where it allows you to take these macros and expand them to certain variables. And in Grafana's case, like the time start and time end range, those are automatically populated in some global variables. And you can just get them in your data source implementation and just re add them back to your SQL query that is sent to Pinot. So that's usually how things work. And this is good enough for the most part. Like people are completely okay with doing this. But as you will realize, and I think you might have seen this already, this query is only doing a group by broker tenant, and I'm trying to simulate a scenario where I'm trying to create observability on Pinot query events itself. So think of like Pinot clusters receiving queries, and those queries are emitted to a Kafka topic, and we re-ingest them back to some other Pinot cluster. And now I'm querying that other Pinot cluster to derive insights on how my queries are doing. But as you can see here, like we have the notion of broker tenant, which is the label or the series in the time series speak, but I don't have a notion of time here yet. So this query is not really going to work to create a panel like this. But what you need to do is you need to add like a date trunk or some sort of time bucketing notion here so that you can group data into hourly or minutely chunks. And that way you have your pretty lines on a graph kind of visualization, which starts giving you insights about how things are doing. But as you can see already, the date trunk syntax is kind of weird. Like it's not weird in the sense like it, it has to be complete, so it is complete. But at least for a general user, like there is a learning curve here. And if I have to write a lot of Grafana dashboards or a lot of alerts, then I don't want to deal with these things again and again. And these are also very error prone. Like if, for example, if let's say my column is not a seconds column, it's a milliseconds and epoch column, then which of these parameters I need to change? At least I don't remember right now. I think it was the third parameter in the date run call. But that is where people start having issues with the experience already. But you could say that you can fix this particular experience problem with another macro. And here you you create a macro called time bucket seconds. So this is different from the one I'm using in filters, which is generating a filter. But here I'm essentially expanding the time bucket seconds to a date run call. And I'm taking in the user expression, and I'm also taking in the time granularity that users want to query the data at. So this is decent. This works well. I would say like this is also quite doable and quite scalable for a lot of users. So we're good so far. But what usually happens is that in the previous graph, I was looking at hourly data, and hourly is almost never good enough for time series data. You are at a minimum looking at minute level granularities because anything that you're monitoring, you want to be able to see the different trends within an hour also. To see, like, if let's say there was a spike within a given minute, then those won't show up in the hourly resolution. So you're always trying to go for a minute resolution or even like a 10-second resolution. But in this case, let's say we go with minute resolution and we end up with a query like this. Uh, and I'm isolating one particular series here to show you what the issues are. But the issue here is that the data is coming out to be incomplete. Now, this could be because of the data itself. Maybe the data itself is not complete and we have gaps in the data. But in this particular case, like because I created the data, I know that there are no gaps in this data. So, but what is the reason for like why are we getting this particular like a lot of dots here and not our pretty lines? Where are those? So the issue here is that we're doing a group by on broker tenant and the time buckets, but we have to put a limit. And you might not have noticed so far, but I was using limit 1000 throughout the previous slides. And if you use limit 1000 here, then this limit applies to the number of unique broker tenant and time bucket pairings. And in this case, I'm looking at somewhere around like 12 hours of data. So in 12 hours, that is like a lot of minutes, already around 5,000 or so minutes. And those would easily exceed the limit clause. So even for a single series, I will start having partial data already. I think I misspoke. It wasn't 5,000, it was somewhere around 500, but that doesn't matter. Like in the end, the point is that the time buckets get multiplied with the series, and your number of data points become very high as you start to increase your time range. And that is where you have to now worry about what do I set my limit to. So in this case, like I set my limit to 100K, and that is working reasonably. Like I see that data is coming out correctly. And I also verified through manual means that after 3 p.m. here, the data was actually having gaps. So this looks okay from a correctness point of view. But if you were try to if you try to look at the last 7 days or the last 14 days or the last 21 days and so on and so forth, you will realize that the number of minutes is, they just keep on increasing. And then your limits go for a toss. Like, for example, if let's say you go with 100K row limit for 7 days of visualization, you can only do 10 unique series. And with 1 million row limit, you can only do 100 unique series. And this is for 7 days. Like, it's very common for people to look at the last 14 days, the last 1 month, because they are usually interested in looking at, okay, like for example, let's say my Pinot cluster is having an incident because of high traffic, which I assume to be high traffic. Now, my first question would be like, is this high traffic new, or has this been happening in the last 7 days or 14 days? And that is where you start with, let's say, the last 6 hours of data, because let's say the incident started happening 10 minutes ago. Then looking at the last 6 hours is good enough. But then the next level of insight is that this been happening before as well? And that is where you look at the last 7 days and last 14 days and so on and so forth to get a sense of whether whatever is happening right now is an anomaly in the truest sense, or is it just an anomaly compared to the last 24 hours. So that is where the limits thing becomes an issue. But again, you can say that I can work around these limits by setting them to a very high number. And that is fair also. I think you can set it to like 10 million or 100 million or whatever. But the issue is that if you provide a SQL interface for users, then users have to deal with this. And if let's say you wrap it into your own UI layer and you still use SQL internally, then you still might have issues, which we'll talk about. But another way to like solve the limit issue is you can try to change the resolution of the data automatically. So if let's say someone is looking at the last 7 days or last 14 days or last 21 days, it doesn't make sense to like have the same time resolution of let's say 1 minute or 10 seconds for all of those time ranges. You might want to increase the resolution as you are increasing the time range that you're looking at. And that is where you can say that, okay, I'll build a macro which will automatically compute the right resolution for every query. And then I'll still go with my 100K limit or 1 million limit or 10 million limit. And I'll use that and I'll try to live with that. So that also will work to some extent, but there are like issues with this which I won't get into, but you'll still hit more issues. Even if let's say you consider the previous problems as solved problems, there are still more issues to be solved. For example, the biggest one that people have an issue with is dealing with gaps in data. And gaps in data look something like the figure tries to show on the right. So essentially we have some data at 1 p.m. and these are like count data I'm trying to show using the dots. So higher the dot, the higher the count, basically. So at 1 p.m. we have a high count, at 2 p.m. it dipped a bit. At 3 p.m. and 4 p.m. we don't have any counts. And suddenly at 5 p.m. we are back to normal count range. So issues like these, like you want to fill gaps with a specific value, and specifically you want to fill it with a non-null value. The reason being that handling null values becomes a question in every interface you will deal with. For example, let's say you're trying to divide two series and you're trying to compute, let's say, the success percentage. Then if you divide by null, then that is undefined. So that leads to like a special behavior of like, okay, how do you want your nulls to be division by null or null by some proper number to be defined? And alerting UIs or dashboarding UIs might have their own semantics on handling nulls. And usually you try to avoid them as much as possible. And you try to convert them to a normal value, which is a integer value or a numeric value, so that you can clearly show that in this case, for example, these are counts. So transforming a null to a zero is the right approach here. It also makes sense from user perspective. It also makes it easier for the dashboarding tools and the alerting tools and all the semantics that come from there. So that is one of the common requirements. There are many other reasons why you want to do gap filling, but this becomes a challenge with SQL, and more generally, this is also a challenge for relational operators. And the reason for that is in the relational model, you will have something like a table. So our query in the previous diagram, I'll go back quickly. So in this case, I'm doing a group by again, I'm doing a count star again, and have data at 1 p.m., 2 p.m., and 5 p.m. from a visual perspective, the output of this query would look something like this, where you have time bucket 1 p.m., 2 p.m. you have data, at 5 p.m. you don't have any data. As in at 3 p.m. and 4 p.m. you don't have any data, and at 5 p.m. you have data again. So how do we generate rows so that they are inserted in the middle of these, or even if they are not inserted in the middle of these, like insert them anywhere, like insert 3 p.m. row after 6 p.m. also, that is also fine. But how do you tell the relational operator that you want to do this? And that is a challenge with the relational model itself. It is possible to do it, and we'll go over like how to do this. So usually your operations in the relational model, they're of like the most common ones are transforms, aggregations, and joins. Transforms are essentially your project kind of relational operators, which is essentially a select clause. And these map one row to another row. So they don't allow you to insert rows. So they might not be helpful in our case. Then we have the aggregation operator. In the aggregation operator, we are able to reduce the number of rows and also compute a function on the input rows to, let's say, compute a count or a sum or whatever. But it still doesn't allow us to insert new rows based on a certain time definition. So aggregation might not also work out here. But could joins work out? Joins can work out, and that is what a lot of people end up doing. So they either go with like a custom transform function where the transform function runs towards the very end, where if let's say you feed it input like the one I'm showing on the left, then it will automatically scan through the data, and there will be like some sort of custom logic implemented to detect, okay, this is like hourly data and I'm missing 3 p.m. and 4 p.m. time slots. So it will automatically fill it in with like some value that you can configure in the query itself. So the custom transform function is pretty common, and that is what most SQL databases do, including Pinot before the time series query engine. So Pinot has this gap fill function, which is still there, and that gap fill function runs towards the very end of the query, and it does basically what I said, which is do one final pass of the result of the query and fill in gaps wherever you can. So that is one of the most, there are a bunch of other databases that do it. I won't get into the names, but another approach is to do joins. And in the join case, what you would do is you can have a table just for the time values, and then you can do a left join of this particular output with the time value table. You can use joins this way to essentially fill in data, but in the end, the issue still remains is that the query becomes very complicated. And in the end, users have to write these queries and they have to not just deal with gaps, but also like they want to do more after this. They just don't want to stop at gap filling. They might want to do more, as I'll show in the rest of the examples. But yeah, what are the other things that they might be interested in? So they might be interested in doing week over week comparisons, where let's say I am looking at query counts or let's say Uber Eats order volume. Let's take an Uber theme example. And I want to track whether week over week I'm losing orders or I'm gaining orders. And if let's say the orders go beyond, like if they reduce beyond a certain threshold, then I might want to be alerted about them. So that is why like week over week comparisons are like very common. And these are so common that a lot of observability platforms, they support them out of the box also. But I won't get into again like the details of that. But that is how most people, a lot of people do anomaly detection in the platform world. Then you also have requirements of doing time shifts in queries. So time shifts are used for week over week comparison, but they can also be used for, let's say I have a Grafana panel and I want to chart the current query count and I want to chart the 1 week ago query count in the same panel. Then I might want to use a time shift to shift the time from whatever the current time is by 1 week or 1 day or whatever I'm interested in. So that way I'll have two lines on a graph on the graph. One will show the current query counts and the one will show the week old query counts. And that can be really helpful to track again, like do week over week comparisons without doing divisions yourself. And then you have moving aggregation requirements. So moving aggregations are quite powerful. And the biggest advantage that they support is they allow you to smooth your data without losing resolution. I'll show one of the examples in one of the later slides. So these are some of the more requirements that come from observability use cases. And doing these with SQL becomes quite complicated. Like, for example, the moving functions, at least based on our experience running Pinot at scale with like hundreds of users and probably I think thousands of users at this point internally, most people are not familiar with window functions, which is which you need to use to be able to do moving aggregations in SQL. And expecting them to learn that as well as support it at scale and combine it with a bunch of other functionalities is quite complicated. And similarly, with timesheets and week over week comparisons, we can try to patch SQL in a lot of ways to make it work. But in the end, it's a lot of new things for the users to learn, and they already have like a lot to learn, right? So we don't want to worsen the experience for them, even if we can say that theoretically we can support whatever they're asking for. And there are some existing requirements already, which we talked about in the previous slide. So we want like a simple syntax for time filters and bucketing. We achieved that through macros. We want a simple way to do gap filling, and we want intelligent time resolution in the sense that if I'm looking at minute level data for the last 24 hours, that doesn't mean I want minute level data for the last 30 days. So ideally, the observability platform should automatically change the resolution on its own, and the user shouldn't have to worry about things like these. And that is where the time series query engine comes into the picture here. And the way we have built it in a way that you can run any time series query language against Pinot. Uh, PromQL is one of the most popular and open source languages. Uber uses M3QL, which is also open source, but the community is not active anymore. And a bunch of other companies have their own languages, like a bunch of other cloud platforms also have their own languages. So the first thing is you want to be able to run any time series query language in Pinot so that if let's say a company has a preference for a certain query language, they shouldn't be bound to using PromQL or M3QL or something else. So we have made it in this way that the query language itself is completely pluggable. And this engine works with all existing tables. You don't need to update your table or you don't need to create new tables. It continues to work with existing tables. So that was one of the biggest things we wanted out of this engine because we don't want to take the overhead of migrating all of our tables to a new version of table. Right? We just want people to be able to query their existing tables with a better language for this particular use case. By better language, just for clarification, it's for like observability, but I understand people get quite touchy on that subject. Um, but as you want to like support thousands of QPS with millisecond latencies, this is because in a bigger organization, you will likely have thousands or millions of alerts. So you want to be able to scale to a place where you can support them in a cost efficient manner. So we built the time series query engine with that in mind. And we also support n-ary join operations, such as you can do division of series, you can do percentile of series, and so on and so forth. And the join is essentially between expressions here. I'll show examples to show what joins mean here. But for the rest of the examples and for the rest of the slides, I'll take this particular table as an example. Again, this is like a Pinot table, which is storing Pinot queries data. So just it's much easier, I guess, to understand from a user perspective. So the first thing you might want to do is you might want to track the query count for your Pinot queries. And I'll use M3QL as an example here. But an M3QL plugin is something that we have built internally, and we might try to like open source it at some point in the future. And I know that StarTree has already built the PromQL plugin, so you can probably reach out to them if you're interested in the PromQL plugin. But yeah, so I'll take the M3QL example here. You have this M3QL query. The simple query already gets you to a place where you have lines on the graph. Like the time resolution is auto computed, time filters are auto computed. And I'll also walk you through like what the syntax means, because I think not everyone would be familiar with it. But what this query is doing is essentially a sum where we don't have any filters, and we're doing a group by on broker tenant. And the table is specified using the table clause, as you can see there. And the value, so the for each row in your Pinot table, you want to impute the time and the series and the value. So you want three things to be imputed from every row in your table. And the table is already configured using a explicit variable. Value is also configured using an explicit variable. So you can put in one here, you can put in an expression here, and that will become the value for that particular row. So for example, you can put in a column name also here. Like it could be total dogs, for example, in the value tag here. Then you can put in your filters to filter out certain filter out certain rows, and you then specify what aggregation function you want to use. In this case, we want to use sum, and I want to do a group by on broker tenant, which is what I've specified in the query. So with this, we have lines on a graph, but in this case, like we still have the gap fill problem. But in this case, the issue is not because of limits. The issue is because of actual gaps in the data. So if your data actually has gaps, then you need a way to do gap filling. And in SQL, like I mentioned, like Pinot already supports a gap fill function, but that's quite hard to use. I think you can look at the documentation online for it. In M3 world, it is very easy. It's just a single word. And I'll go back to the slide again just to show the transition, but you go from like a gap full data to a gapless data. And you can transform nulls to zero or any custom value. So that is also allowed. And it's very easy to essentially chain these operations and do whatever you want with them. And going back to like, I was showing the single series example, like going back to all the series. Now we have all the series here. And you can see that transform null again, like it's very easy to use. But it was very spiky. So going back, like the graph here is super spiky, and it's usually not a great experience for users to have to deal with. Even if, let's say, you have auto resolution turned on, if usually for like a 12-hour or 10-hour kind of window, you still might be interested in minute level data, but the you still want like finer resolution, but you don't want a lot of spikes to be there. So the way to resolve that is to use moving functions. And in this case, I've shown like moving 1 hour sum as an example. So as you can see, like we have eliminated all the spikes. And at the same time, I can also see that the smaller spikes that are happening within an hour. For example, if you look at between 1 to 2, I can see that the increase happened gradually and it wasn't sudden. And similarly, between 4 to 5, I can see that the dip happened gradually and then the increase happened gradually. So that is the advantage of doing smoothing with moving functions, because you don't lose out on resolution. This data is still like 1 minute resolution, but you get rid of the spikes, and that is quite useful in most of the cases. And again, it's very easy to add in M3QL. It's just a few words compared to SQL, where you have to like write window functions or something else. And similarly, you can do hour over hour, day over day, or week over week analysis. So in this case, I'm doing hour over hour query counts, and the query looks something like I've shown here. So in this case, what I'm doing is I'm figuring out the 1 hour ago query count, and I'm figuring out the 2 hour ago query count. And I am adding both of them and dividing by 2, which means I'm taking an average of them. And then I'm taking the current count as a percentage of the average of the last 2 hours. So that again is like pretty easy to do. And you can do gap fills at any point. You can chain operations very easily. It's like very easy to evolve this for your particular use case. Because one of the things with observability is that you start with lines on a graph, but you start realizing that whatever lines that you are ending up with, they either have gaps, or they are not, or they're too noisy, or they are not fitting within the threshold that you want to set them into. So you have to iterate quite quickly, and you have to iterate a few times to get the alert, the query right, and the graphing query right. And these languages really make it easy for you to do that. So, and by the way, like all of these, going back to the previous slide, like all of these are actual examples from the tables, and other things are anonymized, but these are actual examples from our production where this is the actual query that can run in our clusters. And same with the previous M3QL queries that I was showing. And the best part is that you still have access to SQL, so you can still use it for things like, for example, pie charts. Like I wouldn't want to use a time series query language like M3QL for pie charts. Like SQL is much more intuitive there, so you still have access to that, and that is where Pinot becomes, in a way, a complete system for querying for observability use cases, and that is really, really powerful, at least based on the user feedback we have received so far. And the way we have built this pluggable, I just take like one slide to go over this, but the way we have built this pluggable query language framework is by making the planner and the plan nodes and the operators themselves abstract. So Pinot core doesn't really know about M3 operators. It only knows about the base time series operator. And that way I can implement my own time series operators without having to worry about what Pinot wants or what dependencies Pinot wants. I can just focus on my particular semantics, like how I want to handle nulls, for example. And Pinot doesn't care either about M3QL or PromQL. It just runs the plan nodes and the operators and the planner. And the entire thing is very abstract in a way. So that way, the Pinot core execution framework only deals with the SPI, and you get to dictate your semantics and your plans and your language by yourself. And like zooming back, right? So because I think we were going deeper into this to understand how where the time series query engine fits into the current landscape. But if you step back, then you realize that in the bigger picture for observability, Pinot can already do all of these things. So it can do metrics, it can do events, it can do logs, and it can do traces. And this is just for like observability I'm talking about here. And from query perspective, you can do SQL and you can do time series query languages after this particular feature of ours. So with that, like Pinot has become truly a complete solution for observability use cases. And if you step back even further, then realize that with Pinot, you get user-facing analytics, high QPS, millisecond latencies. You get a complete observability stack in the sense that you can support observability on events, you can support it on metrics, traces, logs, and what have you. And you can use your own query language, or you can use SQL as it is supported in Pinot. Then you have support for distributed joins, which can be powerful for some power users or some marketing kind of use cases, or a bunch of other use cases where data is partitioned and you just want to do joins. Those are still supported. Pinot has support for upserts, which are quite popular at Uber and I'm sure everywhere else. And we also support ingestion from real-time and batch sources. So in a way, as long as you have data and you want to do something with low latency and you want to analyze it in any sort of way, at this point, Pinot can pretty much do everything. And in the bigger picture, I think that is where this particular feature really helps move us forward. So from the observability stack point of view, it really helps complete the picture there. And it tries to make Pinot a complete solution for almost all of your data kind of needs, be it analytics or user-facing analytics or interactive analytics and so on and so forth. And what's next for time series query engine? So I'm just talking about a time series query engine here. So we are working on a stable release. Right now, we have still marked this as experimental. We have onboarded a bunch of alerts already at Uber. We have around 100,000 to 200,000 alerts running on this already. But to graduate from experimental to a matured state, we still need to make some changes, and we'll be making them over the next few months. And we'll be adding support for exemplars, which are a very popular feature in Grafana and as well in a bunch of other visualization tools. And there are like some minor implementation features, but and there's like a lot more coming, but I'll probably share them in a future talk maybe. But yeah, that's all I had, and thanks everyone for joining.